Hello and thanks for watching. In this video we're going to go through the Supremum, the Infimum, and the Completeness axiom. So before we start, I'd like to quickly define what we mean by bounded or bounds in general. So suppose we have some function f that goes from r to r. We say that f is bounded above if there exists some b, so some value b for which x is x is less than or equal to b for all, or even fx, for all x in R. So that is, if the function is smaller than some value for every point in its domain, then it is bounded above. For example, say we have a simple graph like 1 minus x squared. This is going to look something like this, and as you can see, there does exist some b for which fx is less than it. So for example, b can be equal to 2, which would be like somewhere here. B can be equal to 3, should be somewhere here. What I'm trying to get at is that this b does not have to be unique at all. So this is a bound, this is a bound. The bound is not unique. Now we say that f is bounded below. F is bounded below if there exists some b for which fx is greater or equal to b for all x in R. So this is just the same definition as before, but with the opposite side, which makes sense. Bounded below, there's a bound below. So if we instead go with 1 plus x squared, we have a bound here, we have a bound here, they're all bounds. And in general, we say that f is bounded if it is bounded both below and above. So an example of a function like this is cosine of x, for example, which goes like this, which we have some value for which it's smaller than, let's say this can be like 2, we can have minus 2 here, and you can see that cosine x is bounded. Okay. Now, that's nice. It will help us in many cases, but there's something a bit more, something we want to explore using this. So, the definition of Supremum. Definition Supremum. So a set X is Supremum C if C is an upper bound if B, it's a terrible B, if B is an upper bound B is greater or equal to C. So what I'm basically saying is that C is the smallest possible upper bound. So if we go back here, we saw that this 1 minus x squared is bounded above. The smallest upper bound we can get is right here when it touches. So that is the supremum of f here is equal to 1. The supremum here of cos x is also 1. 1. We, as you saw here and here, we denote C as sup x. So similarly, definition. The infimum set x as infimum C if C is a lower bound and if B is a lower bound, B is less than or equal to C. So this is very similar to the supremum, except the other way. It is the greatest lower bound. So if we look back here, the infimum of 1 plus x squared is just 1. The infimum of cos x is also 1, and similarly to sup x, this is denoted as C is inf x. Okay. Oops. So now I'm going to introduce something called the completeness axiom. And this states, axiom, and this states if x is bounded above, so x exists. So there will always exist a least upper bound if it is bounded in the first place. Similarly, if x is bounded below, inf x exists. Now, a natural question to ask is the supremum and infimum always equal to the maximum and the minimum? So for example, we saw here the minimum of cos x is obviously 1, and that's also the infimum. We saw it with this example here as well, and this example. And the answer is actually no, because the maximum may not even exist. So to give an example of this, let's consider some set x. X is equal to x such that x is less than 2. Now the supremum is obviously sup x is equal to 2. Now notice that the inequality is strict on purpose. So let's suppose x is a maximum k, for example. Now k is less than 2, so we have that k plus 2 over 2 is greater than k. It's just like the midpoint between k and 2. And since 2 is greater than k, k plus 2 over 2 is also greater than k. But k plus 2 over 2 is less than 2. So this means that this is a new maximum. So therefore k is not the maximum. So this gives us a contradiction because we assume that x has a maximum k, but now we just found a greater maximum, so a maximum does not exist. But we have that the supremum of x is 2. Yes, okay. So, to summarize, the supremum is the least upper bound, the infimum is the greatest lower bound, bounded above if there exists some upper bound, bounded below if there exists some lower bound, and the completeness axiom states that if it is bounded above, the supremum exists, if it is bounded below, the infimum exists. The maximum and minimum may not necessarily exist. Thanks for watching, that's all, and I hope this helped. Bye bye.